So probably the last name has its roots, and it's a Celtish last name. They say, my grandfather says, but perhaps he was drunk at this time, but it's hard to pronounce. Okay, thanks for the introduction. Yeah, like mentioned, my name is Bernd Erk, which is stupid to say in English. I don't know how you can do it correctly, so you can name me Bob or something if it's easier. I'm working at Netways. It's a German-based company. We're doing consultancy and stuff like that. I'm one of the co-founders of the Icinga project. We founded the project nearly 5.5, 6 years ago. And what I do in the project is I started doing a little bit of reporting and web, but for now I'm doing most of the project management and doing community things like going to conferences and taking care of the website and all that administration in the project. What Icinga is, Icinga in general is an open source monitoring project. We have our roots in Nagios. The main approach is that we are monitoring things in an active way, so not agent-based. We can do it, but the standard thing and an approach is like going every 5 minutes, going to a system, hardware, switch, whatever, check if it's okay. Getting the availability data and also providing data for reporting and other tools. So, like I mentioned, we originally forked out from Nagios in 2009. This was Nagios version 3 at this time. Reason why, so who knows Icinga? Sorry for the late question. Who knows Icinga? Okay, 50%. Our main reason that we're all long-time Nagios users, but we were not comfortable with the approach and the development speed and stuff like that, and that was the reason why we took Nagios 3 code based into Icinga. But since 2.5 years, we started to redevelop this in Icinga 2, which is from the code totally independent. So we have still some basic concepts taken from Nagios and the old Icinga version over, but the core itself is totally redeveloped. We are a team of about 25, 27 people, distributed all over the world. There are people doing more, people doing less, like in every open source project. Most of them are responsible for, we have a lot of people maintaining the distribution packages and Ansible and Puppet and stuff like that. So we try to bring the people like contributing to specific modules in our project that we have them nearby and have a good communication. But not all of them are really contributing to the main code, but just help us in the community. What we have just in addition is like a plugin platform. So if you're using, you can use it for Nagios as well. We created it last year where you can store plugins and you can search plugins for Icinga and Nagios. An advantage to the existing platforms that you can sync it with your Git repository or your Mercurial. So if you have a project on GitHub or your plugin, you can just place an Icinga Exchange YAML file in there, can write what state it is, the description, and just sync the project with the Icinga Exchange so you don't have to update this catalog every time you're bringing a new feature to a plugin, because that's the worst thing with these dictionaries, that you just upload it once and then it's all there, and then you're working on your code base somewhere else. So yeah, this is pretty cool, and we started it last year in October, and for now it looks like people accepting it, uploading new plugins nearly every day. So it seems to be that it's working. What we have, we gathered a lot of things the last year. So the original Icinga core is the part we forked from Nagios. And now we have Icinga 2, which I'll talk about in detail. We have documentation team, which is responsible for the documentation, which is completely written in Markdown. We have a reporting, which is at the moment a little bit outdated, to be honest, because we are thinking about moving it to the web interface. It's based on Jasper reports. It's an open source reporting framework. And we have a couple of web interfaces. So at the moment we have 3 interfaces. We have the classic UI, which is the old ugly Nagios CGI interface. We have an old new web interface, and now we have a real new web interface. And the target is that with Icinga, which should be Icinga Web 2, we want to replace the old web and the classic UI in the near future. It's not finished. So we're in beta 3 at the moment. It will be ready, I think, in 1.5 months. But then the focus is like replacing the old interfaces and just having one for small setups, for enterprise needs, and also for mobile, and having a responsible layout for that. So, but today's focus will be on Icinga 2, Icinga 2 Web. and I'll talk a little bit about that. So in general, if you never heard about Nagios Icinga, what it does, it monitors, that it's just looking for servers, for infrastructure, hardware, and it nearly can monitor everything with the network connectivity. And if you don't have any network connectivity, there are a lot of sensors talking SNMP, so if you want to check if a door was opened or closed or something like that, you can do it. We're doing alerting, so the typical thing is mail, text messages, voice calls, which means voice calls is the only thing where you can be 100% sure that the people who was notified really accepted. So you can do something like read the message with text-to-speech and say, please press 4 for accepting the error. But it's not so easy to set these up. So email is pretty easy, and voice alerts using asterisk or whatever phone box you have is a little bit more work. And then as a result of the monitoring, providing data for graphing, for reporting. You can write to ROD files. In Icinga 2, we have Graphite support included, so we can directly write to Graphite or InfluxDB. We can write to OpenTSDB, and we can also write to Graylog or Logstash. So we can directly write everything to that GELF format, which is the Graylog extended log format, and then write it to Logstash or Graylog. But we can also work with accidents happened in the log file, and then, for example, launch a notification in Icinga as well. So our strategy here is not reinventing all the tools out there. So we want to make sure that we work great with tools like Graphite and InfluxDB, but not implementing our own time series database or something like that. So we want to integrate with them, and that is our main target at the moment. So Icinga 2 is based on C++. One bad thing in old Icinga and Nagios, it doesn't scale. If you use it with a couple of servers, then you see that there's only one processor is 100% and all the others doing nothing, because it's a single C loop process. So the new one is multi-threaded, works on Windows as well if you want it. So we have an installer. But our primary focus for Windows is not seeing it as a server platform for Icinga, but perhaps as a distribution hub or an agent where you want to install Icinga. But it's not our primary server platform. But it works. We compile it using Jenkins every day, so it should work there. We support MySQL and Postgres, but it's not necessary that you have a database. So you can monitor and you can set up distributed monitoring without database. But if you want some, and for some reasons like reporting, it makes sense to set up a database, you need to go with one of these. We have a lot of modules for Puppet, for Chef, for Ansible, for all that config management tools out there. You find models for Icinga 2. It's really easy to install it automatically with a config management. And we have packages for all main distributions and Vagrant boxes as well. Is Vagrant, everybody knows Vagrant, what it is? So if you want to try it out, this is too small. We have an own Git repository which is named Icinga Vagrant. If you want to give it a try later on, I have that in the slides repeatedly at the end. Then you can just check out the Git, and then you can decide what you want. Icinga 1, Icinga 2, Icinga 2 cluster, or Icinga 2 with Graphite. And just say a Vagrant up, and then it's setting up one machine, two machines with Graphite. So whatever demo setup you want to see and to check, it's really easy using that with Vagrant. So the basic architecture of Icinga is that the core Icinga 2 provides all the basic things the monitoring needs and the basic API, like it's named libicinga. And all the other things you know from the old Icinga world, all the features that you can now enable or disable them. Means you can run an Icinga server somewhere without any job doing. It doesn't make sense, but you can decide what to do there. So you can say, I have a server node somewhere, and the only thing I want to do there with Icinga is writing data to the database, or writing perf data, or read configuration, or executing checks. So all the features we have in Icinga, you can enable and disable them via command line. You can say Icinga feature enable Graphite, and then this node writes to Graphite. If you have a mashed up cluster, so multiple nodes, and all the nodes sharing one knowledge, you can write the same data on all nodes to Graphite if you want to. So you can decide what you want to enable. A typical setup is sometimes that you have your nodes doing reporting, writing to the database, writing to Graphite, and you have other nodes which are responsible for doing the check work and doing the checks out there, but you can decide how you want to manage it. Somebody of you knows live status? Somebody uses it? It's for Nagios and Icinga, it's a module, it's an event broker module where you can make direct queries to the core. So you can get information out of the monitoring core without writing the data to the database and reading it out, or I don't know, querying the log files. And this is the event broker module. In Nagios Icinga is a little bit hard to install, and in these screencasts is just an example how easy it is, and see a little bit of the command line because it's hard to demo. Just like we have that command line which has auto-completion with tab, you can say Icinga 2 feature enable live status. This is the only command you have to set up. Then restart it. It's a little bit too slow, so I was too slow recording it. What happens if you restart, if you enable that feature, that Icinga creates a socket which is named live status, and there you can directly read or write out information from the monitoring core. And then you can just access all object types in the monitoring for hosts or services or host groups. I just do an example query here, that live status query, where I say I want to get specific information about services. As I get services, then I say the columns of the service, of the service checks I have in the monitoring. I want to have the state, I want to have the host name and the description, for example. But you can access all monitoring objects you want to. And then I just store the file and then cut the query file to the pipe. And then you can directly access the monitoring core and every node of the cluster. And it's really fast and it's really easy to write something with it. So it's just an easy way to access the monitoring data, and it's not hard to set this up. Does it make sense? Do you understand what it does? So you can query all the other objects like hosts and host groups and stuff like that. Just a small example how easy it is to access the data. The configuration. In Icinga 2, in the early phase where we decided to do something new, we discussed if we have to break up with the old configuration. And it took only about 5 minutes that we said, okay, we have to. Because the old configuration in Nagios has a lot of limitations. For example, you only can have one interface per host, which is not a real production scenario everybody has. So there are really limitations. On the other hand, it's a challenge because if you say to the people you have to reconfigure your configuration, you have to learn something. Sometimes it's easier to complain about old things, but you don't have to learn something new. But then you do something new, people say, oh, I have to do everything from scratch. But we decided it would make sense. It makes sense to do new things. So it's different. We hope that you won't miss the old configuration. So if you want to go to Icinga 2 or go from another monitoring software to Icinga 2, then it's not a problem. But going from Icinga 1 on Nagios to Icinga, you have to rethink the configuration. And just to give you a little bit of an example, this is a service definition in the old Nagios Icinga world, where you have a service and then you add this service to a couple of hosts. You can do it via template, for example, but a typical config looks like you have a specific section for service or host group, and then you have lined up all the hosts which are needs to be configured. And in Icinga 2, you can do something with an assign. So you can apply services in a config management way. So you can define templates and can assign, in this example, the service SSH to every host which has an address and is a Linux. So we can give sometimes variables. It's something like facts if you're using Puppet, and you can assign rule-based monitoring. Another thing is, for example, host groups. Host groups in Icinga, in the old version, means defining a host group and then adding all the host group members. In Icinga 2, you can do something like that. So you're defining an object host, and then you have a dynamic host group where I said, I want to assign all that servers where the host name matches MySQL to that host group. Means if you're adding a new host, if you're adding a switch, whatever, which hit that rule, then it's added automatically. You can combine these assign rules like in SQL. You can have an or an and. You have a couple of chances to do that. And something new in 2.3 is, in this example, it's a little bit hard to come in, but perhaps take a second. You can now access every object in the monitoring system. In this example, we can access a time period. And what we can do here is we can set dynamic thresholding based on the time zone a service is in. So we can say, at this time when I check, is the time period 9 to 5? Is it inside? So I'm in the time period 9 to 5 at the moment. Then you can define a threshold 40 or not. Then you can define a threshold 60, which makes totally sense. For example, take a disk as an example. You want to deal with a disk if it's on 80% perhaps during the day, but you don't want to wake up somebody for 80% disk at night. And this is what you can do. You don't have to define it. For every service, you can write these in a template and then apply it to all the services you're using it. We have support for conditionals, we have types, we have references, so it's kind of like a language. The only thing you cannot do is like writing files or reading files, perhaps at the moment, but you can do all the other things. You can loops, you can, for example, define arrays. With all file hosts you have on an Apache server, you can define array, write down every virtual host, and then apply the whole array to the service and monitor every virtual host. You can do that very programmatically. It takes a little bit of a time, but so far the feedback we get is that people using that features, and the more complicated it gets, then we have the feeling that the people like it more and more. They're spending time doing crazy things and sending us 200 lines of code they developed in the configuration. We never thought that you can do this, but yeah, you can do that. So people love it. We were not sure if we're going a step too far, but people really using it. And you can also do something like business processes and can correlate state of server ABC and give a complete result out of them. You can do that as well in the configuration. So clustering, in the old, or in a typical Nagios Icinga 1-based setup, it's hard to have distributed setups. So there is the only thing you have, you can transfer files. You can write perf data and transfer it using NSCA, or copy the files via SSH or whatever. So if you have a distributed setup with Nagios or any other monitoring system, sometimes it's really hard. If you have a Subbix, for example, then you have proxies out there. But distributed setup, spoken of a geolocation problem or specific network zones, is a challenge. And we were thinking about how we can make it a little bit easier. And in Icinga 2, we have a cluster support based on certificates. We have a zone support which gives you a chance to have multi-tenancy. So you can have one monitoring system, but then have multiple customer zones in that. Then everybody is isolated in his zone, but you can have a master zone which sees everything. And we have an API for that. And how it works, all the communication between all the Icinga clusters, if you have more than one, is going via using a single port, using SSL, all the commands, the perf data, everything using a single port. We have a bidirectional configuration. It means you can go to a specific network zone or you can accept an incoming connection from a specific zone. We have something like a bin log retention. Means if you have a zone somewhere else and the network connection is broken, then it stores all data locally. And then if the connection comes up again, it transfers everything back. That at the end, you have a 24/7 perspective in your database, getting an SLA report later on, because it's not important for incident management to get the old data, but for reporting, it's important that you have everything later. If we have multiple checkers, so it scales very well. With a dummy C check, we can do about 500,000 service checks on a desktop. 500,000 in a minute interval. This is what we can do for now. But performance in these fork things is really hard because it depends on what plugin you're forking. So if you have a 40 megabyte Perl monster you are executing, then it's not so fast. And if you have fast C checks, then it's running faster. But for a normal setup, it's not necessary to have more workers. But if you have more, then the workload gets redistributed automatically. So if you have more than one checkers, all the checks get distributed. And also the configuration is distributed automatically. So how that looks like? In that example, we have 3 Icinga nodes. And here you can see in that area that we have, for example, write perf data and do checks on this node. And we can write to a database on the other node. And we can, for example, enable these live status I show you on another node. So every node shares the knowledge of these instances. If they are in the same zone, you can query every data everywhere. And what we find out, for example, if we have a database over there and try to write to a remote database, just insert the monitoring data to MySQL. It's faster to install Icinga on the monitoring server and use the Icinga protocol, transferring the data to the MySQL server and then write the data locally, is faster than remote writing to a MySQL database. So in larger setups, we do so that on the MySQL server, we install Icinga, and the only feature we enable is the IDO feature. The only things it does is writing to the database, nothing else. The communication works with SSL, and then we write locally, and it's really faster, like writing from a remote system to the database. If you have specific network zones or specific hosts you are not able to reach or you cannot reach from a technical perspective, in this example, you can create zones. So the typical setup is that you have one master zone, and every Icinga server in that zone sees everything. All the configuration could be distributed automatically. So if you, for example, add here a new host and restart Icinga, the configuration is automatically transferred to the other node. It's validated there, and if it's valid, then it's restarted. You don't have to go somewhere to a remote box and restart it. But you can have multiple zones. If you have multiple zones, it could be very complex, very fast, because then it's hard to see which object is in which zone. Then people complaining it's not in my database, and they say, yeah, because your Icinga database node is not in that zone. So if you go into that zone area, it could be a little bit a challenge, but if you need that, it makes sense to take the time for that kind of setup. The cool thing is that you have a chance to do geo-replication, monitor multiple customers with one big setup, automatical distribution of your configuration, everything in a single box, and then you have to take care of your design and your architecture to do so. Icinga Web. We have the old classic UI I mentioned, and then we have Icinga Web 1. Somebody knows the Icinga Web 1? So not the classic UI? Not a lot of people use it. So the time we forked Nagios 2009, we said, okay, we need definitely a new web interface because the old Nagios CI sucks. And then we decided to do it with XJS, because at this time, rich internet applications were totally hip. And then we decided, okay, XJS is pretty awesome. It's just copying 10 lines of code, and then we have a grid and buttons, and everything will go automatically. But this was not a good decision, because we spent most of the time enhancing and working on that XJS framework than extending the Icinga web. So over the years, it took us a lot of work bringing XJS always to a state that it runs on all the major browsers and stuff like that. So looking back, it was not a good decision doing it with XJS, but it's always that looking back, you're knowing better then. And so we said we need something new. Icinga Web 2 is based on PHP. The reason is simple. It was the language the web developer were able to write. There is nothing against Ruby or whatever, but we had experience in PHP, and this was the reason why we chose it as well. We're using a Zen framework in version 1. We modified it a little bit for our needs to have it easier for the routing and stuff like that. We provide multiple authentication providers for internal DB, so we have our own authentication if you want to. You can use Apache out, you can use LDAP, you can use Active Directory, you can work with groups. We support multiple backends, so we can have one web interface supporting multiple out providers and also supporting multiple data providers. So if you have multiple Icinga instances, and Icinga Web 2 can work with Icinga 1 and Icinga 2 because they use the same data model in the backend. You can have multiple backends and read from them. And we have also the support for failover backends. Means you can read from the database, but if the database goes offline, for example, then you can go back and read from the live status directly from the core if you want to. So how it looks like. The framework for Icinga web is Icinga PHP library, which gives us a chance that we can also access the status information via command line. So we have an Icinga CLI where we can get status data out using it. We're taking care in the basic framework of the backends, authentication, and an installer. So it's installed like a WordPress. You throw everything into a folder, and then an installer comes up and asks you for your monitoring backend and for your users and for your modules. And that is the basic foundation of Icinga Web. The basic monitoring framework of Icinga Web has no idea about monitoring. It's just the basic framework, and monitoring itself is a module. So monitoring and documentation, that are the only modules we ship with Icinga Web. So if you download it, monitoring and docs are in there, because without any module, perhaps it doesn't make sense. But from the technical perspective, monitoring is a module, as same like business processes, like Graphite, like PNP, and all the modules are coming up in the next time. They are totally developed independent. It's just a folder you put in there, but you can define your own roles, so you can bring your privileges with the module. It's very easy to extend. And to show that, I prepared a demo, which hopefully works. Okay. So this is how, the landing dashboard of Icinga Web 2 looks like. The basic concept of the web interface right now is that we have a little bit different approach of master details. So getting detailed information on specific hosts and services means in the old web interfaces, like leaving the context, opening a new tab, or adding a new tab to your browser. And we decided doing something like a column design. So all the details are coming up on the right column. You can go through that columns if you want more information. So I'm going to see a service problem here right now. You see the plugin output. You can recheck a service. It's pretty easy. For example, the recently recovered, you see the graphs. You see on this host, you can, for example, really easy access all the other services on this host. And if you go to detail over there, then it just goes to the right side. Going to the services, then you just see that I'm moving from one column to another, and this design concept is completely realized in all the views in Icinga Web 2. So if we go back to a service check, for example, you have the command here, like passive and active and stuff like that. You see the graphs. You can exit the graphs. This is done via an add-on. This is used with PNP for Nagios. If you know that, it's one of the easiest ways to write Nagios Icinga perf data to an RRD database. And it's just a module download. You can that on Git, and then it's pretty easy. We have a search for the whole object base. Means you can here see hosts with Win, services, a host group, and in the host group view, you also see the different service states in that host group. So we have also a summarization how that host groups looks in general. You can, let's go to another view. You have the same in the host group overview as well. So if you see the host groups, you see the state, the total services, the state of the services. And if you go here, you see the host group and can directly drop into the detail and see that. You can have something like a multi-selection if you want to submit a check or a comment for multiple hosts or services. You can do it very easy, like pressing like Shift. And then you can reschedule for all checks or check them now. And that's it. So in the old interface, like rechecking a service is like, I want to recheck now, and then yes, which takes about, I don't know, 10 seconds. No, if you're fast, it takes 2 seconds. But it's not handsome. It doesn't make sense. And this is pretty easy. You can, every action is normally should be just a single click. So going from seeing a status, want to do a recheck, or I don't know, creating a downtime for a specific check should be very easy. Okay, thank you. I have to go here, sorry. We have something like a timelining. This is only available if you're using the database as a backend, where you can go back in time and say, I want to see what really happened on a specific year or month, what we had. Do we have a lot of notifications at this time, a lot of acknowledgements? How was the activity on the monitoring system balanced during the selected time periods? So in the yearly view, it's a little bit hard to see. In a month, most of the things are. So you can see that there was how many notifications, that there were more notifications in June. You can go into the detail, see them all, see the notifications, and you can also go directly to the history for that service and see all the events happened on a specific service during the time. You can go through them very quick. I hope 500 was not too much, but normally it works. Another thing is the service metrics or the event grid. In my demo system, it's not so cool because I set this up yesterday. But what it does, if you're thinking about the GitHub landing page where you can see code contribution activity for a user, you have that colored matrix. And this is what happens here. So if you have a lot of alerts over time, you can see what are your typical hotspots. So is it always a Monday, always a Tuesday, or is it a specific day of a month? You can see very easily because these days will be, if it's more red, then you have more problems on the day. And sometimes if you just have 20 servers, you normally know where the problem is, or you know the problem servers. But in a bigger environment, sometimes it's really hard to find out. You're working and opening tickets automatically, but you have no clue where the problem comes from. And this gives you a really good overview. What we have as well is something like a business process view, where you can combine multiple service and host states to a service. In this example, it's a web service. And the web service as well is not a real technical service, it's just a business process. And it consists of a couple of services needed to be available. For example, in this case, the web service needs a MySQL server and need a web server. And then you can see on the left side that you can combine them together via AND and OR rules and can say, I need web service. For a web service, I need MySQL and I need Apache. But I can live if only one server is up here. So in this example, I have 3 database servers and one is down, but my business process is still up. So bringing a service perspective in monitoring is the big issue as well. You can define multiple services. DNS services is pretty easy. And you can do also something like a simulation. So for example, if you have a complex service, let's take this an example. Then I can say I want to assume that this service is down and I want to see what the impact is, something like an impact analysis. If you have multiple rules, this example is pretty easy, so you can have an overview in 2 seconds. But if you have a rule which consists about of thousands of servers or hundreds, then sometimes it's really hard to see what is the impact. If this server goes down, what happens later on? And with an impact, you can do so. You can also have something like a grid. If you want to bring it to the monitor or having a dashboard, you can do it this way. And if the service goes down or is not available, then you get a visual alert on that and can see what's happened over there. You can filter with complex rules. So all the basic views you have and something which didn't work with the old interface, you can access every window, every thing I did in the past using the browser history, which was horrible in the old interfaces because but like you can see, every column, every change is accessible via browser history. So if you share the URL, you can send somebody else, he gets exactly the same view, independent from local caching or session files or something like that. So it's pretty easy to share. You can filter them. For every host group, for host state, service state, you can create complex filters. And you can also add these filters to the dashboard. So if you filtered something and said it's host group company 1, Then you can add this to dashboard. Then I give it a title. And then it's there. You can export every page to JSON or a PDF if you want to, or a CSV. So you can just do a wget or set and work with the data as well, or can use the live status, whatever you want. But yeah, just to give you an overview about what we have for now in the interface. We have support for NUGVIS. Somebody knows NUGVIS? It's a visualization map. Some people like. I hate it because I think it doesn't make sense. But it's an add-on for doing doing maps, doing something like this. Okay, this is a bad example. Let's say something else. You can have a data center, you can put a server in there, and it can do also with geolocation and maps and things. I don't know. If you need it, we have it. If you want it, it's your fault. No, it's just a joke. So some people like it. It makes a lot of work doing that maps, and I don't see perhaps it's a management thing, and therefore it could be an argument for the technical thing. If you have your things in order and you have good dashboards, then it's more easy to go to a service view to your problem and doing a root cause. But perhaps if you don't know the technical infrastructures, or for people who are watching on the monitoring at night and would just want to have a clue what's going on in their setup, that could totally make sense.
I think if you have a data center the size of, say, Facebook, so something like that would probably be very useful.
But then normally everything is red or is green.
Yeah.
Yeah, that's the problem in the old monitoring. So in old Nagios and Icinga, there was something like a status map where you see the host and then the parent-child relationship. But in a bigger setup, it was like a lot of balls and lines, and you see nothing, and everything was red or green. And it's the maps. There are auto map features in NUGVIS, so you can place all the hosts in there and create me a graph related on parent-child relationship. But these manual drawn things are to be honest, we only have setups we know which are in public sector which are doing that, where they have young people going a training, they're doing for 3 months drawing these kind of maps. But normal people don't have the time to do so. But anyway, if they have the time, what's going on? I think I showed most of the thing. One I'm missing is the event overview. Hold on. I don't know why the service grid not working. The service grid is empty, or is it empty over here? Another view we have is the service grid, where you have all the hosts, or it's lined up by hosts or by services. And if they share services, specific services on all the hosts, you can see in that grid that there's a relation between them. And in this demo system, you see, for example, in Active Directory, that it works on none of the hosts, perhaps leads you to a specific storage. Or if your MySQL database works nowhere, if your MySQL service goes down everywhere on every host, then you have perhaps a problem with your central MySQL server. It's the same thing. If you have 3,000 hosts, then you can do that. So we have a navigation bar. But if you found that problem really fast on a couple of thousand hosts, I'm not sure about that. Okay.
Are the business rules and NUGVIS modules, is there config for those also replicated in the cluster as well?
No. For the business rules, you can do so. For NUGVIS, not so far, but probably you can do so. The business rules and all the other files are pretty easy to replicate. You can use the standard mechanism from Icinga. The only thing you have to do, there's a configuration parameter, say accept configuration, that you configure a server that he accepts configuration parts from another one, from an upstream or a parent server. But you can also provision it via Puppet or whatever you want to. It's just one way. And the business process rules you can transfer the same way.
So essentially you can write your own business rules in config files and distribute them.
Yeah.
You don't have to use that.
Yes.
Cool.
So at the moment we don't have a configuration interface, so we don't have anything like a wizard where you can create hosts. We want to have something in summer. In general, with all that config management hype going on the last years, there's a revolution that all the tools with CLI and config and config files coming back again, and people like them because it's easy to work with Ansible, Puppet, whatever. But there are also users which like to just add a host and using a specific template, which don't want to using VI do so. So we'll have set, and this is planned for August this year. Okay, I'm nearly finished. So a couple of users we have. So the problem is we don't know which uses Icinga, because most of the people are installing it using the distribution of the system. One thing is not listed. We know that HP is monitoring their private cloud using Icinga 2. Icinga 2, they have their own monitoring product, HP, but they're using Icinga 2, which is a funny story. Somebody in San Francisco told me that, yes, our tool does not work, so we're using Icinga 2. But we are not allowed to place the logo, but I can tell the story. Adobe is on Icinga 2 as well. Audi is a part of them on Icinga 2. There are more and more people are using it. So if you are using it and would like to share it with us, it would be really helpful to do so. We're doing, it's the wrong slide. We're doing some camps all over the world. So we had one in Singapore 2 weeks ago, and we have one in Kuala Lumpur, and the next one is in Antwerp. With somebody who's going to Load Days in Antwerp in April. And then we have an Icinga camp on the following day, covering Icinga, but also other tools like time series databases and log files and stuff like that. So monitoring related stuff on the day. So conclusion, if you want to give it a try, if you want to play on your notebook, just use Vagrant, use the packages, don't build it on your own. So you can do it. You can still download the source code from Git and compile it, but please don't do that, because it's hard to maintain. There are questions coming up because people have no clue about linking and how it works, and you need a couple of libraries because you need boost libraries and stuff like that. And we really have packages for, if you need it for large setups, we have Raspberry Pi as well, if somebody needs it. So you can really have everything on our package side, and please use them. It makes it much more easier for our developers that people are not coming to IRC and not able to compile the software, which is really hard to be investing a lot of them. So rethink your configuration. If you have an existing Nagios on Icinga, perhaps give the configuration a try. It's very well documented. We have a docs.icinga.org where you can find everything, all the language references, every field in the live status API, the DB schema. Really everything we have is documented. You can read it there. Install Icinga Web 2. So it's beta 3, but it works. And give us feedback. And that's it for now. So if we have perhaps time for questions, if somebody has a question. And so far, I would say thank you for listening. Thank you.
Hi, we'd like to try a bit more. Cluster's probably not the right word, but a central master aggregating checks from other Icinga installations. If you have, say, a child Icinga installation embedded in an OpenStack chain, for example,
okay,
is it possible to just have that, you configure that tenant's checks on that instance, and then have that replicated back to the master? Is that a single zone? Is that multiple zones? Is that how?
No, you can do that. So there are different ways to do that. But one thing is, if you have multiple nodes or you have a specific agent where Icinga installed, you can say, I want to execute this specific check from this host. So in the config, there's a specific attribute where we can say, I only want to gather this information from a specific host as a remote node check. You can do so. But how you want to set up your cluster, it's totally up to you. You can say, I have distributed things, but you can only, as in a cloud environment, say you need 2 or 3 monitoring servers because you know that you need them to handle the massive checks. then you can bring them automatically, and if they are on the same zone, one master, so one Icinga node, it's not necessary that they only have one master server. You can have multiple zones. So a single Icinga server can connect to 3 or 4 others, and if they are not there, then he uses an alternative route. So he knows if he's got a chance to, I don't know, send the information back, and if one of the upstream servers is down, he uses another one. So if a server goes up and down in the cluster, they recognize it on their own, distributing the configuration and do everything automatically. So you don't have to take care if the machine comes up or down. So it's done automatic. And you can decide if you want to do checks on a specific server or do all the checks on another one or do checks just on 2 nodes. You can decide what you want to do.
Okay, thank you very much.
Thank you.